the software life cycle model. We have seen about the classical waterfall model, the various phases. You remember. Now, after this, we have one of the other uh, model that is the iterative waterfall model. So the shortcomings which was there in case of classical waterfall model, we try to improve that with this iterative waterfall model. So basically, when we say iterative, what do you mean? Is anyone can say? Okay, all right. Anyone else? What is iterative? You must have come across this word very often, isn't it? Anyone? What is iterative? Yes, anyone? Abhishek, Mahanta, what is iterative? Any idea? Or Teet Agarwal, any idea what is iterative? Arbas has said something which is repetitive, isn't it? So others, if someone can add, anyone else? Shankaran, what is iterative? Can you add something? Yes, anyone else who can
Repetition.
add what is iterative?
Repetition.
So, okay, one of you have said that iterative is basically a repetition of a process, isn't it? Okay. The same thing here also. Here also, what we do is in iterative waterfall model, we provide feedback paths. If any error is detected, that can be corrected as well. Okay, so it's not that we have gone to a particular phase, we cannot retract back it. Here, we'll be able to retract and make the corrections. So the advantage of this model is that there is a working of the system at a very early stage of development, which helps us to know uh, the shortcomings or the demerits that a particular design may have. It's much more easier. Also here, since it is an iterative process, like we keep on rechecking every now and then, so we can take corrective measures on various limitations such as economic constraint, efforts, time taken. So we become very much clear. This part is very much given more focus here in this model phase. So this becomes much more better. Problem with this model is that it is not suitable for very large and bulky software development systems. Okay, so that is one of the demerit because in this case we are unable to break down a smaller software system smaller modules or parts. Becomes difficult because if we are targeting to build a very bulky large software project, point to build the entire system at one go becomes very difficult. Okay, so that is one of the constraint in this case of iterative waterfall model. overcome this one, we have another call, that is the prototyping model. So the word is derived from prototype. So what do you think? What is prototype as per you? Yes, anyone who can say? Okay, okay. Anyone else? Anyone else? Anyone else who can say?
Okay, so
Okay, so
Arbaz said that
Arbaz said
it is a
that
kind
it
of
is a
a
kind of
model,
a model,
or you can
or
say a
you can
kind
say
of
a
a
kind of a
blueprint, right?
blueprint,
What you
right?
are
What you
trying
are
to
trying
say.
to say?
Okay,
Okay,
very
very
good.
good.
Yes, a
Yes, a
prototype is
prototype
a
is a
kind of
kind of
a
a
blueprint or a
blueprint or a
model of
model
a
of a
particular
particular
system.
system.
That means
That
we
means
try, we
we
prepare
prepare
a
a
blueprint of
blueprint of
how the
how the
system
system
would
would behave,
behave,
what
what
kind of
kind of
input it
input it
would
would
take,
take,
how the
how
screen
the screen
interfaces would
interfaces
look
would
like,
look like,
okay, what
okay, what
kind of
kind of
output it is
output it is
expected to
expected to
produce.
produce.
Okay, so
Okay,
those
so
things
those things
are
are
being
being
considered
considered
while the
while the
model or
model
the
or the
prototype is
prototype is
being
being
built.
built.
Another
Another
reason
reason
for
for
developing a
developing a
prototype
prototype
uh,
uh,
is
is
that it
that
is
it is
very
very
difficult to
difficult to
build
build
a
a
perfect
perfect
product
product
in
in
the
the
first
first
go.
go.
So
So always
always we
we
need
need
to
to
have
have a
a
model
model of
of
to
to
reference
reference
so that
so
we
that
become much
we
more
become much more
clearer.
clearer. Yes, that's
Yes, that's
yes.
yes. Okay,
It
it is
did close.
close.
Okay. Okay, now is it okay?
Yes, sir.
Yeah. Okay. So the main reason for uh, going for the prototype is that at one go to build a very large system is very difficult. So if we have a model for referencing, that it becomes much more easier to know what we basically want. Okay, how the interfaces would look like, how the system would produce outputs, what kind of input it is being suggested, and the system would take. So all these consideration becomes very much easier in case of a prototype modeling. A prototype model also is used extensively when technical solutions are not clear to the development team. So suppose if we have a project, the team is not sure. So what they can do, they can develop a model first, a prototype first, and then they can develop at every stage, okay, the model, and that becomes much more clearer. Okay, so a prototype when developed, it helps the developers, the engineers to examine the technical problems that may be there with the development of the product. It is seen that most of the time, major design decisions, mostly the challenges that takes place in the design phase are mostly for the following, like what will be the response time of a hardware controller for a particular heavy software, how long will the hardware be able to support, okay, the efficiency of the algorithm that is being used. So all these considerations are like taken very much strongly in prototyping model. Okay, so but then again, when this kind of models are being used, because there are many models, but we need to be clear about in which situations and in what kind of development environment basically that particular model will be feasible. Okay, so a prototype model basically will be preferred in certain situations when the user requirements are not very concrete and complete. Okay, so that time maybe for going directly to develop the system will be a risk-taking time. So it is advisable that first you need to develop a prototype, okay, and then maybe you can proceed accordingly. Similarly, if the technical specifications are not very clear in which system you are going to develop, what kind of front end you will use, so all these things when it's not clear, then that time basically you can go for the prototyping model. So this is basically the the block diagram of how a prototype model phases would look like. Okay, so first of all, like we basically, as we have seen in the waterfall model, also we start with um, the requirements of the system or from the client side, isn't it? We do the requirement analysis and gathering whatever it needs to be done. We prepare the software requirement specification, isn't it, to list down the requirements, and then we proceed to the design phase. Now, in the design phase, again, we just directly from the design, we just don't jump into implementation. But what do? We first build a prototype, a particular model. Then we discuss that with the client, that whether this is good or not, or are you happy or not, or can we move to forward with the development or not. So, if suppose the client is happy, then you can say we can proceed to the development. But if the client is not happy, then what do? We need to do? We need to redecide on the gap areas of the prototype. We need to review that, update that, and then again we need to add those missing features. Okay, develop a comprehensive prototype, and then again we review with the customer whether that is okay or not. So that process goes in a cyclic way till until and unless the customer is not happy and satisfied. Once the customer is satisfied, then what happens? Then the person can proceed towards the development phase. Then once the product is being developed, it will go into the testing phase. It will be deployed on the client side, and accordingly, maintenance will be carried out. So this is one of the most important models of of the life cycle model, the prototyping model. So you might be asked questions like what is the motivation for a prototyping model, isn't it? Then what is the need of a prototype in software development? That questions may be asked. Okay, what kind of situations will be feasible for a prototype model? Okay, and what are the phases? So these are the phases of a prototype model. Okay. Then next is what we have is the evolutionary model, which is sometimes also called as model. Okay, so at first a simple working model is built in case. Okay, so as time passes by, it goes on improvement. That means we keep on adding new functions, new features. Okay, and we keep on adding new functions till the desired system is built. Okay, so we start with a small working model, but we keep on adding, you can say, new features and new functions, and the updation and improvement keeps on going until and unless we have reached the target system. Okay, so where does it find application? So these are basically very much helpful when we have very large and bulky kind of projects. Okay, so what we can do, we can divide this into modules for incremental implementation. So often used when the customer wants to start, suppose other features also later, or it looks for expansion, the client, then this incremental model is much more better, because initially maybe we may not be given any kind of specification like, this many modules only will be there. Later there may be enhancement. So at that time evolutionary model is much more preferred. Okay, so also suppose if someone is using object oriented software development approach, then this because the system can be easily be portioned into smaller units in terms of objects, then the evolutionary model also can be chosen in that. Now, what are the advantages? So these are the two advantages that we can think. It will reduce the errors that one may commit, because there are many core modules and those modules needs to be tested thoroughly. Okay. And other advantage is that the user gets a chance to experiment or to execute the developed system partially one by one. So if suppose one part of the system is developed, that is tested and executed. If the other one is developed, then again that one is tested and executed. So in that way, the partial developed system is experimented in phase wise. Okay, making the possibility of making any kind of error is reduced. What is the disadvantage? It is difficult to divide the problem, however, into several versions that would be acceptable to the customer, which can be incrementally implemented and delivered. Okay, so the other part is that it is difficult to divide the problem, that means the system, into several versions that would be acceptable to the customer, which can be incrementally implemented and delivered. So disadvantage is that no doubt we go for an incremental approach, but the thing is that we cannot divide the system into like smaller parts and then deploy one by one to the client side. Okay, so that is not acceptable. Maybe on our side we can divide that into smaller sections and then work it out. But on the client side, it has to be delivered as a whole, not part wise. Okay, so that is basically one of the disadvantages of this kind of model. So from here itself, we can understand. So first of all, let's say for example, when the concept of software is being built, then what do? We move to the preliminary requirements and analysis. That means we will try to understand what is the requirement or on what system will it be much more feasible. That means we will do some kind of software like information gathering will be carrying out on the client side of what the customer basically wants, and accordingly we will perform an analysis. So there we need to do a cross check whether whatever analysis or whatever uh, information we have acquired, whether that is sufficient or not. If it is not sufficient, then we again go back and we check whatever concept we have thought. Is there some loophole or something that because our analysis is not perfect? If that is fine, then we can proceed to the next phase. So next phase is similar only. What we need to do is we need to design the architecture and system core. That means we need to be aware about what kind of uh, technical specifications we will be using. Okay, we have to make decisions what front end, back end, what in we will be using, in which platform that the system will be running. So all those considerations we have to make during the design phase. What do? We develop a prototype, isn't it? Okay, we develop a prototype and then accordingly we work on it. We implement that design, whatever we have developed. Okay, and then we deliver on the client side, that means on the customer side. Okay, now what we have to do, the customer will check, isn't it, will test whether whatever he had stated in this phase, whether that is same as while the product is made, what was there in the paper, whether that has been practically being implemented by the developer or not, isn't it, whether he got all the satisfactory results or not. So he will check. So after being delivered, then we will the developer or the team has to wait for the customer's feedback. If the customer feedback is very good, so if suppose let's say if the customer feedback is good, so it's fine, we have deployed that and we need to maintain it from time to time. But if suppose there is certain kind of changes or certain updations has to be made, or if the system was not built as per the um, the vision of the customer, then we need to incorporate those changes and we have to make certain updations. And if everything is fine, then ultimately we can deliver that, okay, to the client side. The next is the spiral model. So this is also one of the most important uh, from among the life cycle models. Okay, so here if you can see the spiral model of the software development is shown here. So there are four quadrants if you see, isn't it? Or sectors also. You can see these are the activities which are being carried out during the uh, spiral model of system development. So this diagram is very, very important from the examination point of view. So first of all, what are the things that we need to look here? So suppose if the objective is identified, like what we are going to do. So after that, what we need to do is we need to go into this phase. So once we are in this phase, every phase, there will be a kind of a risk which is associated with every part of the project. There will be a kind of a risk. So how do we tackle that risk? So that is basically spiral model is very good. That is the risk management. So if you see here, it's every you can say phase there it will pass through all these features at least once again, isn't it? So one of the part will be like risk management, prototype development, then designing of the system, coding. Then after that, once the code is being developed for all the modules, we need to integrate. Then once if the codes all are integrated, we need to test it. and then we have to implement. So once that is done, then only we are going to release the product. Okay. Yes, 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 yes. They are repetitive in nature. So that will, yes, yes. It is repetitive. It will keep on, like uh, repeating until and unless we have like attained all the objectives. Okay, so that will keep on going. All right. So, but it will be like phase wise. Like it's not that even if this is repetitive, but it has to finish this entire phase, come in this way. Okay, and then again. So that way, like again, the same thing will be revisited, kind of thing. Are you getting the point? Okay. Now let's say there are how many quadrants? If you see, there are four quadrants, like one, two, three, four. Okay. So let us see one by one theoretically what they are trying to say. So first quadrant is objective setting. So what do we need here is in the first quadrant, basically, we need to identify like the objectives. What is our aim, basically? Okay. Then once we have like identified the objective, we have to examine the risk associated with these objects. Like, okay, this okay, we have aim that we are going to make the system in this way. These are the various aims or the objectives we need to fulfill. But what are the risks that is associated with all these objectives? Do we have any risk? If yes, then what we need to do? Then we need to go into the second quadrant. So in the second quadrant, basically, we need to assess the risk. That means we need to find out, we need to calculate, we need to quantify, okay, what are the various risks and how much percentage of risk will be harmful for the development of the system. So if suppose those risks are identified in a very percentile way, then how we are going to mitigate or reduce those risks, that thing has to be clear. Okay, so how do we do that? We need to do a detailed analysis of every identified project risk. Okay, we need to analyze that this is the risk that is we have identified. So how we are going to mitigate it? Okay, so steps are taken. So we need to ensure that we eliminate such kind of risk. Okay, so for example, if there is a risk that the requirements are not appropriate, we don't have complete requirement with us from the client, and then we need to develop a model immediately, because if we don't have proper requirement, then probability that the system will never see the light of the day, isn't it? So those things we have to be very, very critical about it. Then when we enter the third quadrant, okay, so in that phase, it's little once we have mitigated the risk, identified it, we have reduced it, then what we need to do now, we have to develop, correct? So once we have developed that, we need to check, we need to validate that whether the product that is being developed is risk free or not. Okay, because this product has been already been developed after mitigating or reducing all the risks which are involved. So once that is done, what do? We go to the fourth quadrant. So we review the system or the product that is being made. Okay, with the customer, we sit down and we check whether everything is fine or not. If everything is not fine, then again we need to go in the same cyclic process in the iteration around the spiral model. And if suppose everything is progressive and everything is fine, then we can deploy this on the client side. Okay, these things I'll talk about in the next class. Okay, so these life cycle models you have to know very, very nicely. Okay, so you can write down the questions for your assignments. Okay, write down the students. First, you will write what is software engineering. Someone can write what is software engineering. You have to do on your own. Okay, this assignment. What is software engineering? What is the need of software engineering? What is the need of software engineering? These are all one question only. What are the characteristics of a good software? What are the characteristics of a good software? The next question number 2. What is the software development life cycle? What is what do you understand by software development life cycle? Question mark. What is the need of a software life cycle model? What is the need of a software lifecycle model. Question number 3. Explain in detail with suitable diagram. Explain in detail with suitable diagrams. This comes for 7 marks in question paper also I've seen. Explain in detail with suitable diagrams about various life cycle models. Various life cycle models. Here. Then the last question, question number 4. List out the advantages and disadvantages. List out the advantages and disadvantages of the various life cycle models. So you have to give three points each. List out the various advantages and disadvantages of various life cycle models. Okay. Take this assignments by next week. Maybe you can submit by Tuesday. Okay, it will be like soft copy only, so you need not write. Or if suppose someone wants to write also, it's up to them. So after this, maybe tomorrow in the next class, I will start with a very important topic, requirement analysis and specification. Okay, so this is very important because from your project point, you have to know this. Okay, so that is the reason like I'll be giving more focus and you people also have to work. Okay. So Shankaran, you can take the attendance for today.